Good day everyone, welcome back to our teaching series. Today we'll be discussing the topic partial fraction. Now we are going to be explaining the concept of partial fraction using some examples. And our very first example is from NECO 2004. It states that resolve into partial fraction 2s plus 1 divided by s minus 2 in bracket s plus 3 in bracket. Now the whole concept of partial fraction is to split our bulk fraction, which is this fraction we have, into the two original components fraction from which this is gotten, and obviously we don't know those two fractions. Now our very first step is to say or assume let our expression be equals to two other fractions with the same denominator. That is, we are going to be splitting our denominator s minus 2 and s plus 3 into two of the components. So one of the fraction will be taking s minus 2 and the other fraction will be taking s plus 3. So let 2s plus 11 divided by s minus 2 in bracket s plus 3 be equivalent to a divided by s minus 2 plus b divided by s plus 3. So we know that our two fraction is a divided by s minus 2 plus b divided by s plus 3. Now our whole goal is to find the value of a and find the value of b. Now the way we go about this is to multiply both sides by the denominator, which is s minus 2 s plus 3, to multiply through by that so that we can remove the denominator from both sides. Now doing so, that is multiplying through by s minus 2 s plus 3, we get 2s plus 11 is equals to a in bracket s plus 3 plus b in bracket s minus 2. Now we are going to be making this equation 1. Obviously we cannot be solving for a and b at the same time, so the way we do that is that we try and eliminate one of the constants by substituting a value of s that will make that part be equal to 0. Now we know to make the bracket s plus 3 be equal to 0, we are going to be putting minus 3, for instance, because we know that minus 3 plus 3 will be equal to 0. And to make the bracket s minus 2 to be equal to 0, we are going to be using 2, because we know 2 minus 2 is equals to 0. That's the whole idea with partial fraction. Now put s equals to 2 into equation 1 to eliminate b. Doing so, it becomes 2 in bracket 2 plus 11 is equals to a in bracket 2 plus 3 plus b in bracket 0, because 2 minus 2 is 0. Then we'll be left with 15 is equals to 5a. Dividing both sides by 5, we get the value of a, and a is equals to 3. Now we repeat the same steps to eliminate a. To eliminate a, put s equals to minus 3 equals to into equation 1. Doing so, it becomes 2 in bracket minus 3 plus 11 is equals to a in bracket 0 plus b in bracket minus 3 minus 2. And simplifying, it becomes minus 6 plus 11 is equals to minus 5b. Minus 6 plus 11 is 5, so it becomes 5 is equals to minus 5b. And dividing both sides by minus 5, b will be equals to minus 1. So at this point, we are going to be substituting the value for a and b into our original proposition. Doing so, 2s plus 11 divided by s minus 2 in bracket s plus 3 will be equals to 3 divided by s minus 2 minus 1 divided by s plus 3. We have another question, and this one is from NECO. It states that express s plus 3 divided by s minus 2 in bracket s plus 4 in bracket in partial fraction. Now solution, let s plus 3 divided by s minus 2 in bracket s plus 4 in bracket be equivalent to a divided by s minus 2 plus b divided by s plus 4. Now our next step is to multiply through by s minus 2 in bracket s minus 4 on both sides. Doing so, we are left with s plus 3 is equals to a in bracket s plus 4 plus b in bracket s minus 2. This will be our equation 1. To eliminate b, we put s equals to 2 into equation 1. Substituting s for 2 in equation 1, it becomes 2 plus 3 is equals to a in bracket 2 plus 4 plus b in bracket 2 minus 2. The b component is going to cancel out because 2 minus 2 is 0. We are left with 5 equals to a in bracket 6 plus b in bracket 0, which will be equals to 5 is equals to 6a. Now dividing both sides by 6, we have a is equals to 5 over 6. Our next step is to eliminate a. Doing so, we put s equals to minus 4 into equation 1. So if s equals to minus 4 in equation 1, it becomes minus 4 plus 3 is equals to a in bracket 0 plus b in bracket minus 6. So therefore, minus 1 will be equals to minus 6b. Dividing both sides by 6, b will be equals to 1 over 6. Now, substituting for a and b values into our original proposition, s plus 3 divided by s minus 2 in bracket s plus 4 will be equals to 5 divided by 6 in bracket s minus 2 plus 1 divided by 6 in bracket s plus 4. Our next question is from 1994. It states that if 10s plus 1 divided by s minus 2 in bracket s plus 1 in bracket is equals to k divided by s minus 2 plus 3 divided by s plus 1, find the value of k. So in this case, we are just looking for k. Now, solution, we are going to be multiplying through by s minus 2 and s plus 1. That's solving our partial fraction. Doing so, it becomes 10s plus 1 is equals to k in bracket s plus 1 plus 3 in bracket s minus 2. Since we are to find k, we are going to be eliminating the 3 in bracket s minus 2 by putting s equals to 2. Doing so, it becomes 10 in bracket 2 plus 1 is equals to k in bracket 3 plus 3 in bracket 0. 3 times 0 is obviously 0, so we are left with 21 is equals to 3k. Dividing both sides by 3, k will be equals to 7. Our final question is from 1994. It states that resolve 1 divided by arrow in bracket arrow plus 2 into partial fractions. Now, for our solution, let 1 divided by arrow in bracket arrow plus 2 be equivalent to a divided by arrow plus b divided by arrow plus 2. That's we are dividing it by our denominator. Now, our next step is to multiply both sides by arrow in bracket arrow plus 2. Doing so, it becomes 1 is equals to a in bracket arrow plus 2 plus b arrow. Let this be our equation 1. Now, to eliminate b, we put arrow equals to 0 in equation 1. Substituting arrow for 0 in equation 1, it becomes 1 is equals to a in bracket 0 plus 2 plus b in bracket 0. The b part of our equation will cancel out because b times 0 is equal to 0. So we are left with 1 is equals to 2a. Dividing both sides by 2, a will be equals to 1 over 2. The next step, to eliminate a, we put arrow equals to minus 2 into equation 1. Now, substituting arrow for minus 3 in equation 1, it becomes 1 is equals to a in bracket minus 2 plus 2 plus b in bracket minus 2. A in bracket minus 2 plus 2 will cancel out because minus 2 plus 2 is 0. So we'll be left with 1 is equals to minus 2b. Dividing both sides by minus 2, it becomes b is equals to minus 1 over 2. So therefore, our a is equals to 1 over 2 and our b is equals to minus 1 over 2. Now, the next step is to substitute for a and b into our original equation. So substituting a and b value into our initial proposition, it becomes 1 divided by arrow in bracket arrow plus 2 is equals to 1 divided by 2 arrow minus 1 divided by 2 in bracket arrow plus 2. Here are some exercises for you to try your hands on at home. And for more insights on this topic, you can check out the chapter 28 of our Hidden Facts Further Mathematics textbooks. You can easily get the hard copy in bookshops, or if you are interested in the soft copy, you can get it at the website on the bottom of the screen.